Hey guys, so I just wanted to do a few examples of this assignment with you so that we're all on the same page and we know how this works. So this is a magic pixel picture. We've done one of these before with Half-Life in chemistry. For those of you in physical science, we'll get to Half-Life a little bit later. But basically, this is just one of those assignments where you type in the answer, and if your answer is correct, these pixels over here on the right hand side will pop up with the color, and then when you're done there will be a picture at the end. So today we are counting atoms, so I figured we could do a few examples of all the different situations, but of course you want to make sure your notes are done before you tackle this, because how to do this are in those notes that you did in today's lesson. So let's go ahead, we're going to do 3 examples with 3 different types, so just a normal compound, a coefficient, and then ones with subscripts as well. So let's go ahead and do number 1. So here we have CO2, that's carbon dioxide, and we just want to know the number of atoms. Now this particular assignment does not ask you for the different number of each atom. We'll do that a little bit later. It's just wanting to see if you can count up the total number in the compound. So here we have CO2. I don't have any parentheses and I don't have any coefficients, so that means we just have the subscripts. So remember, if you don't have any subscripts on an atom, that means there's one of them. So it's assumed to be 1. So here we have 1 carbon and we have 2 oxygen. So that little 2 there tells us we've got 2 atoms of oxygen in this compound. So 2 atoms of oxygen plus 1 atom of carbon is going to be 3 total atoms. So we will type in 3, and then here you can see that I've answered that correctly, so my pixels have colored and popped up. All right, so that's how you do those, and then let me find one with a coefficient, okay? So here on number 6, let's go ahead and do this one. So we have SO3, so that's sulfur trioxide, and we have a coefficient here. So we have 2, basically what this is telling us is we have 2 molecules of that sulfur trioxide. So we have coefficients have to apply to all of the atoms in the compound. So this 2 is going to we're going to have to take this 2 and multiply it by the S, so the number of sulfur atoms, and by the number of oxygen atoms, okay? So basically we're going to take the coefficient of 2 and we're going to multiply it by each of the subscripts. So again, here, 1, we have this imaginary 1 for the sulfur, right? Because there's 1 sulfur atom. So 2 times 1 is 2, okay? So in this whole thing, we know we're going to have 2 total sulfur atoms. So 2 sulfur, and then 2 times 3 is 6. So we have 6 oxygen, and we've got 2 sulfur, right? So again, just where we got that, the coefficient has to apply to both of these atoms, or both of these elements. So 2 times 1 is 2. 2 times 3 is 6. So 6 plus 2 is 8. And that means that in 2 molecules of sulfur trioxide, there would be 8 total atoms. And we know that's correct because, again, my pixels have popped up, okay? So if you have a coefficient, it has to apply to all of the elements and, of course, the subscript. So you're just basically taking that coefficient and you're multiplying it by the subscript, okay? Finally, last but not least, let's do one with a parentheses, so a polyatomic ion. And let's do this one. So we have SiHCO3, and then in parentheses we have 4, okay? Now this is a little bit different. So here's a polyatomic ion that we know because he's in those parentheses. And when we have a polyatomic in parentheses and then we have another subscript outside of it, remember this subscript has to apply to each of the elements in the parentheses, okay? So this 4 is going to have to be multiplied with the number of hydrogen atoms, the number of carbon atoms, and the number of oxygen atoms. However, this 4 does not apply to our silicon atoms because silicon is not within those parentheses, okay? So we are going to have to multiply all the subscripts here by 4, so all the elements in the parentheses will be multiplied by 4, but silicon will not be, okay? So let's go ahead and do that now. So that means we have 1 silicon, because his assumed coefficient, or not coefficient, I'm sorry, his assumed subscript is 1, okay? We have 1 hydrogen. 1 times 4 is 4. So we'll have 4 hydrogen. 1 carbon, 1 times 4 is 4. And then 3 oxygen times 4 is 12. Okay, so just to recap, we've got 1 silicon, 4 hydrogen, 4 carbon, and 12 oxygen. Okay, so 12 plus 4 is 16, plus 4 is 20, plus 1 is 21. Let's see if we're right. And we are. Perfect. So those are 3 examples. So one where you don't have any coefficients or any parentheses. We did an example with a coefficient, and then we did an example with a subscript outside of a parentheses. Okay, so you just follow that method. Use the rules that you used or you recorded in your notes today, and you should be fine. But of course, as always, if you have questions or need help or get stumped on any of them, reach out and let me know, and I'll be more than happy to help you.